Alright, salam everyone. Now this is my second video tutorial after quadratics. It's on functions, and in this video I'll be discussing how to write a function, what is a function actually, and what do I mean by the concept of domain and range of a function. So let's get started. A function is defined as a mapping where every element of the domain, meaning the x values, is mapped onto exactly one element of the range, which is the y values. So clearly domain are the inputs, that are the x values, and range are the y values. These are the output. Now there are ways of writing a function. You can write a function such as f of x is equals to 2x plus 1, or you can write it this way, which will be read as f of x, and f of x follows this function 2x plus 1. So basically x is mapped onto this function 2x plus 1. Now there are other functions such as g of t, where your variable is t, and g of t can be written as t square minus 2t plus 1. Now we know this is a quadratic function, all right? Or you can write g of x in this way as well. So let's do a couple of questions to have a better understanding. Now let's say if you are asked to evaluate f of 2, meaning in a function the x value is 2. So what will be the output when the value of 2 is inserted in the function? Now the function is f of x equals to 2x plus 1. When you insert 2 over here, you get 5. So 2 being the input generates 5 as your output. Similarly, if you are asked to evaluate f of a would be nothing but instead of x, you now have to input your value a. So the output would be 2a plus 1. Get it? Now there can be other functions as well, such as the function g of t. Now g of t is a quadratic function. So the input over here is g of 3t, meaning this time the input is 3t. So in place of t, you will be inserting 3t and evaluating out the result. And this gives you, after simplification, you get 90 square minus 60 plus 1. So this means that when in a function 3t is your input, you get 90 square minus 60 plus 1 as your output. So let's look at some of the mappings of the functions. Now if you have a function f of x is 2x plus 1, and these values over here are your domain, meaning the inputs, your x values, and when you insert minus 2 in the function, you get the output is minus 3, which is, now that's your output. See, so all these values of x makes up your domain, and all these values of your function are your range, or you can simply say as output. Now you need to notice one thing, that each and every value of x is generating a unique value of y. Alright, so if you insert minus 1, you only get minus 1. When you insert 1, the only output that comes out from the input 1 is 3. Alright, so similarly for the other two values as well. So we can say that every element in the domain is mapped onto exactly one element in the range, and such kinds of functions are known as one-to-one function. Such kinds of functions are known as one-to-one functions. Now if you also sketch this function, if you try to sketch this function, we know that it's a straight line function, and you will expect to have a straight line with the y-intercept as 1. So every value of your x generates a unique value of y. Every value of x generates a unique value of the function. So such functions are known as one-to-one. Now the next function we have are many-to-one function. In many-to-one function, every element in the domain is mapped onto exactly one element in the range. But some elements in the range arise from more than one element in the domain. We say that the function is a many-to-one function. Now, why this function x squared is a many-to-one function? Because I can get the same output 1 from by plugging in -1 in the function or 1 in the function. Similarly, I can get 4 as my output by inserting 2, and the same value 9 can be plugged in by getting -3 as well as 3. So such kind of mapping is known as a many-to-one mapping, and it's for many-to-one function. So if a general quadratic equation is defined for all real values, you will expect to have a quadratic parabola, and they are always many-to-one function. If you try to sketch this graph, you will observe y equals to x square looks like this. Alright, we had this discussion in the previous video. Now I can get the same output. Let's say this is any value. I can say this is, let's say I can say this is 4. Now I can get 4 from either -2 or 2. So there are many inputs that can generate the same output. Hence these kinds of functions are known as many-to-one function. Now the next mapping we can consider is f of x equals to plus minus root x. Alright, so what's happening is when you insert 0 you get 0, but when you insert 1, either the output would be 1 or it could be -1. Similarly, when you have x as 25, plus minus square root of 25 would be equal to plus minus 5. So a single output is generating a single input is generating two outputs. Alright, so these are not function. This is not a function because it is one to many. One input is generating many output. So some elements in the domain are mapped onto more than one element in the range. And if you try to visualize this, this is a graph for plus root x. This is a graph for minus root x. And together they are not function. Meaning if you consider the graph from here, if you consider this positive root x graph, yes, this is a function because it's one to one. Or you consider only this minus root x graph, this is also a function. But together plus minus root x is not a function because you will be getting the same output. You will be getting two different outputs from a single input. Alright, so you will be getting this output as well from your x value and this output as well. So this is not a function, and you can see that I can pass a vertical line to check whether it's a function or not. If my vertical line passes through more than 2 points in a function, then it's not a function. So vertical line is used to identify if the sketch is one-to-one function or not. But I can make a many-to-one function a one-to-one function by restricting its domain. So if you just go back to this many-to-one function, I can make it a one-to-one function if I restrict this function from a turning point. Let's say I define my curve quadratic function after 0. So my function is y equals to x square, but it is only defined for values for positive values of x. So this is just a half part of the quadratic function x square. Now why am I calling this a one-to-one function? Because each value of x is generating only one output. Alright, so if your domain is all real values, then this would have not been a one-to-one function, it's a many-to-one function. But if you restrict the domain from, if you restrict the function by, if you restrict the domain, then it's a one-to-one function. Alright, so this brings us to our next concept of finding domain and range. Now if a function is f of x equals to 2x plus 1 and it is defined for x greater than equal to minus 1 less than equal to 1, so you clearly know that the domain is from x greater than equal to minus 1 less than equal to 1, meaning the value of minus 1 and 1 are included. Now it's always better to have a sketch. Alright, this will give you a better understanding of the function. If I draw the sketch of this straight line within the domain given to me, I'll just make a correction. Alright, so the equation is 2x minus 1. So it will be a straight line having the y-intercept as minus 1. So if you plug, now this is your limit, right? At minus 1, when you insert minus 1 in place of x, you get minus 3. So at minus 1, the value of the function is minus 3. And at 1, the value of the function is 1. So this is your minus 1, this is your minus 1 point. Now your function is only defined from minus 1, from x minus 1 to plus 1. Now if I ask you what is the range of the function, the range is the y values. So in your graph, by looking at your graph, you can observe that the minimum point of this function is minus 3 and the maximum value of the function is, when you insert 1 over here, you get 1, right? So the maximum value is 1 and the minimum value is minus 3. So your graph, your function f of x is between minus 3 and 1 inclusive. So this is the range of the function. Now if we consider the same equation but for a different domain, let's say if the value of x was, if the domain was x belongs to all real values, then how would your graph be different? There is no restriction of the domain. The domain is not restricted. It is defined, this function is defined for all real values, meaning you will expect to have a line, have an infinite line like this. Okay, so although it's the same equation, same values, same x-intercept, same y-intercept, but now the domain is that x belongs to all real values, meaning it is satisfied for all real values of x, all positive values, all negative values, and this graph would keep on going. So what will be the range of this function? See, I cannot limit this graph anymore. I cannot find the minimum value or the maximum value. So the range of this function would be f of x also belongs to all real values. So your all real values. Alright. So let's try to find the range of a many to one function. Now as you can see, g of x is x square. The equation is quadratic. Now and the domain given to you is that x belongs to all real values. So if you were to sketch this function g of x equals to x square, you know it very well that it will be a parabola passing through the origin. And the minimum point is this 0, 0. The origin is a minimum point, meaning the minimum value of the function is 0, because as you increase the value of x, the function value is increasing. As you decrease the value of x less than 0, the function value is increasing. So this curve has a minimum value at x equals to 0, and the minimum value itself is 0. Now what will be the range? Range is always from minimum to maximum. Now as you can see that the domain was all real values, so I do not have a maximum point on this graph. The max, it can goes up to maximum to infinite, it can infinitely go up, but I know the minimum point. Therefore my range for the function g would be, so the minimum value is 0, so the function output can have a minimum value of 0, or it could have a value anything greater than 0, as you can see. So g of x is greater than or equal to 0. That's the range of the function. Now what if our same function was restricted to certain domain, -1 and 3? So you can easily evaluate the value. Okay, let's say x is greater than, so let's say the domain is x is greater than or equal to -1 and less than 3, and so we are clear that the domain given to us is from -1 to 3. So we will be looking the same graph but up to a certain domain. So let's say this is -1 and this value is 3. So I'm just focusing on my graph till this window. Now let's find what the value of what the output of the function would be if at -1. So if you plug g of -1, the value you get by inserting is just 1. So you now know that at -1 the value of the function is 1, and the value of the function at 3 is simply 9. Yeah. Alright. So if you sketch the curve from -1 to 3, this is what your sketch would look like. Now if you are asked to give the range of the function, the range is from the minimum point to a maximum point. Now since it's a many to one function and the turning point is lying within the domain, obviously if it's a minimum curve, then the minimum point would not be 1, it would be something else. Now the turning point of this function is 0. It's at 0 and the minimum value of the function is also 0. So the you can say that the range of this function would be from 0 to 9, where your value of 0 is included because the input, the x value was included in the function, the x value was included in the domain, but the value of 3 wasn't included, so I'm not going to include 9 as my output. So g of x is defined, g of x has a range from 0 to 9. Now let's move on to another graph. Let's say you have a function g of x equals to square root of x, and this time it's the function square root of x is defined for the values of x greater than or equal to 0. Now we know that the sketch of the function would be something like this. it's positive root x. So this is how the sketch looks like, and it is defined for x greater than equal to 0. That is why the values of x that I have taken in my sketch are greater than 0. This value of x cannot be negative because you cannot have a square root of a negative number. Now it's clear that the domain is x greater than equal to 0. But what about the range? By looking at the sketch, you can say that the range of the function is, the minimum value is 0 and it can go up to infinite value. So g of x is simply greater than equal to 0. Similarly, if the same function was there but for a different domain, alright, so let's say I have been given a function from x greater than equal to 4 and less than 25, meaning 25 value isn't included, but the value of x4 is included. Now domain is clear that x is greater than equal to 4 and less than 25, but we need to give the range of this function. So basically we are looking at this graph from 4 to 5, from x equals to 4 to 5, right? So from 4 to 25. So I'm just looking at this window. So this would be a rough sketch, but this value is not included, but this value is included. 4, 25. Now I can see that it's a one-to-one function. There aren't any turning points within this. The output at 4 will be, by when you plug 4 into this equation, the output at 4 would be 2, and the output at 25 would be 5. So g of x has a range from 2, so g of x is greater than equal to 2 and less than equal to 5. Now let's move on to another types of function, which are reciprocal functions. Now you should be able to sketch reciprocal functions, have a clear idea how the sketch of a reciprocal function would look like. Now reciprocal functions such as h of x equals to 3 over x minus 1. One thing from the equation is clear, that at x equals to 1 my denominator would become 0, right? So I can't make my denominator 0, which means that this function is undefined at the value of x equals to 1. So at x equals to 1, I'll make the asymptote. This line is the asymptote because my function can take any value of x other than this value, because this is making my function discontinuous. It is undefined at this point. Alright, now what will happen if you keep on increasing x? Since x is the part of the denominator, if you increase x, the denominator will increase and the function will go down, meaning the fraction will decrease. So the sketch of a reciprocal function is something like this, which I'll be just making. But one thing is clear, that my value of the function cannot be 0, right? The value of the function cannot be 0, because if I keep on increasing the value of x to an infinite value, the function h of x would approach 0, but will never have the value of 0. So these are the sketch of a reciprocal function. Alright. Similarly, for any value of x less than 1, you will have this kind of sketch. Now we can see that our sketch, our curve, our function h of x is decreasing with the increasing values of x, and over here if we are increasing the values of x but negatively, so the function is decreasing and it's not defined at x equals to 1. So the domain of this function, this reciprocal function, would be you can say that your x can take any values of the real number but not equal to 1, because this function is not defined at x equals to 1, it's making the function discontinuous. And the range of this function would be same h of x belongs to all real values, and your function h of x cannot be equal to 0. So this function cannot be, it can approach 0 but it will never be 0. So I hope this video was helpful for you. See you in the next part of the function. Thank you.